Hello students and welcome to second PUC Physics. This video is on polarization. This is specially for repeaters batch. Students, please write and practice, and whatever is taught in these videos are enough for your supplementary examination. First is representation of plane polarized light. PPL, plane polarized light. This symbol or dots or this symbol or this symbol. This is for 1 mark, first main. Second, representation of unpolarized light, UPL. This symbol. You can also draw more number of lines or a vertical line with a dot. Here is dot. These two represents unpolarized light. Sometimes in few reference books you might have seen a number of lines like this. That also represents unpolarized light. And there should be a dot at the center. If you draw these two or any one among these two, that's enough. Third, polarizing angle or Brewster's angle. Polarizing angle or Brewster's angle. It is that angle of incidence of the unpolarized light where the reflected light is completely plane polarized. Statement is enough. Brewster's angle or polarizing angle is that angle of incidence of the unpolarized light where the reflected light is completely plane polarized. Diagram is not necessary, but to understand. This is a rarer medium, denser medium, normal drawn at the point of incidence. If this is incident unpolarized light, then there is a reflected component and a refracted component. Reflected ray, refracted ray. If this angle is Brewster's angle theta, then you know that angle of incidence is equal to angle of reflection. Therefore, this angle is also theta. This is R. This should be unpolarized light. So let me use this symbol. Students, observe arrow mark with a dot. Then if this is Brewster's angle, this reflected light should be completely plane polarized. Students, make sure that you draw only dots. So this is PPL, plane polarized light. This is UPL, unpolarized light. And in the refracted, please draw 4 lines with arrowheads, but only for 2 draw the dots. Only for 2 draw the dots, because it is something like the dots, the components dots is reflected and few dots are observed. Actually, this is wrong to say dots. Dots means those waves which are perpendicular to the plane. I hope you can see like this. If waves are perpendicular to the plane of the paper, then they are represented by dots. If waves are parallel to the plane, they are represented by these arrows. So refracted is partially polarized. Partially polarized light. Reflected is completely plane polarized light. If this is completely plane polarized light, then this angle of incidence is called polarizing angle or Brewster's angle. Brewster's law. Tangent of the polarizing angle is equal to refractive index of the material. Tangent of the polarizing angle, tangent tan of theta, is equal to refractive index. Refractive index is always defined with respect to its surroundings. So n equal to tan theta. This is Brewster's law. Students, n equal to tan theta. Remember this, and using this try to frame a statement. Refractive index of a medium with respect to its surroundings is equal to tangent of the polarizing angle. Okay, done. Now derivation of this. This is an interface separating rarer and denser media. Normal drawn at the point of incidence. Students, make sure that this angle of incidence is greater than 45 degree. Okay. So this is the incident plane polarizer light. There should be a reflected component. This is the reflected ray. Here this angle equal to this angle, and make sure that the refracted ray is perpendicular to the reflected ray, like this. Incident is unpolarized. Draw arrows with the dots. Give attention to the diagram. Equal number of arrows and equal number of dots. Reflected should contain only dots. Refracted less number of dots. Dot, dot. Now this is incident unpolarized light. This is angle of incidence. Here it is polarizing angle. Angle of incidence equal to angle of reflection, theta. This angle should be 90 degree. This is angle of refraction. Mn is the normal drawn at the point of incidence. P, this point is Q, this is R, this is S. PQ is the incident unpolarizer light. QR is reflected plane polarizer light, PPL. QS is refracted partially polarized. So let us write statements for all this. Consider an interface XY, XY separating rarer and denser media. At polarizing angle, the reflected light is completely plane polarized, that is this. And angle between reflected and refracted is 90 degree. Now in the diagram, MQN. Here angle MQN, it is a straight angle, therefore it is 180 degree. But MQN is sum of these three angles. Observe theta, 90, R. MQR plus RQS plus SQN equal to 180 degree. MQR is theta, RQS is 90, SQN is R. 180 minus 90 is 90, therefore R equal to 90 minus, take this R, take this theta to that side, theta. Equation 1. From Snell's law, refractive index of the medium with respect to its surroundings is equal to sin I by sin R. Sin I, angle of incidence is theta, by sin R. In place of R, write 90 minus theta. Numerator is sin theta. Sin 90 minus theta is in first quadrant. Since there is 90 here, it becomes cos theta. This is n. Therefore, n equal to tan theta. Tangent of the polarizing angle is equal to refractive index of the medium with respect to its surroundings. Students, write few steps in the beginning, diagram, then these steps. This is for 3 or 5 marks. Malus equation and Malus law. This statement says intensity of beam of plane polarized light after passing through a rotatable polarizer intensity of beam of plane polarized light after passing through a rotatable polarizer varies as square of the cosine, square of the cos, of the angle through which polarizer is rotated from the position that gives maximum intensity. I'll explain this. After explanation, this statement becomes easy. Relation is I proportional to cos square theta, or I equal to I naught cos square theta. So I is maximum if theta is 0, implies put 0 here, cos 0 is 1, I equal to I naught. I minimum if theta is 90 degree. Cos 90 is 0. Therefore, intensity is 0. Now, what is the meaning of this statement? From the position that gives maximum intensity, they are talking about plane polarized light. This is incident plane polarized light. Okay. This is a polarizer. Draw oval shape, then vertical lines. Then these lines can easily pass through these lines, vertical lines. Think this way, that's enough for time being. So this is the position which gives maximum intensity, maximum. Now this is a rotatable polarizer. We have an option to rotate this and measure that angle. Suppose this is the polarizer, this is the incident plane polarizer light. Polarizer is rotated by theta. See, initially it was vertical. Vertical to theta means this angle is theta. What is the intensity after the polarizer means that intensity is given by I naught cos square theta. If theta is 0 degree means polarizer, this is the incident plane polarizer light, this is the polarizer, angle between these vertical lines and this is 0. Here theta is 0. Theta 0 degree means this light can easily pass through the polarizer. So intensity is maximum. Suppose this is the incident plane polarizer light. This is for the polarizer. And angle between this vertical and this is 90 degree. If theta is 90 degree, then these lines, this light, plane polarizer light, cannot pass through the polarizer. Therefore, intensity is 0. Put 0 here. Cos 0 is 1. Cos 0 is, put theta 90 degree. Cos 90 is 0. Therefore, intensity is 0. Put theta 0. cos 0 is 1, 1 square is 1, 1 into I naught is I naught. That is maximum intensity. So intensity maximum for theta 0, intensity 0 for theta 90 degree. 7th, uses of polarides. Polarides are used in sunglasses. Students, please write in states. Students, please write in statements, in sentences. Polarides are used in. Not all sunglasses have polarides. There are special type of sunglasses. They are called polarized sunglasses. Okay. Second, they are used as camera filters. Third, polarides are used in polarimeter, which measures optical activity. Students, you might have heard about optical activity in organic chemistry, right? Levorotatory, dextrorotatory. So that instrument is called polarimeter. In that polarimeter, they use polarides. Good luck. In the next video, I'll try to cover interference and diffraction. Please write and practice. Without practice, if you simply go through videos and if you simply go through different chapters, it won't help you much. This is a biggest secret. Write and practice. Okay? Good luck.